Well, I found this. It's a garage door opener. Have some fun with this today. It's a Lift Master, the professional line, half horsepower Security Plus. This is slightly different than the ones I'm normally used to seeing. Was the chain that goes around and it pulls this thing where it hooks into the garage door. This is slightly different, as you can see. It's got an auger inside. So, no idea what's wrong with it, but we'll tear it down to see how it works. Well, I got the plastic cover off, so it is upside down right now, so this when it's on the ceiling will be facing the floor. Not much to the cover, just two light sockets for the light bulbs and some recording wiring to them. But this is quite interesting inside. So you have your various electronic controls and a decent sized electric motor. Assuming it's a capacitor run induction motor, and this is where you get a belt from the motor that drives the auger that makes the dolly, or whatever you call it, go back and forth. You can see if I turn it, it moves. Okay. Now this up here, you can see the worm gear. It's various gearing, and so you have the worm gear that turns this gear and turns this other screw, and this is your switch for how far this travels, which controls how far your door goes. And you have various set screws for it right there on the side. Turn it that way, I guess the lift. There we go. My bad, there you go. This is how you'll be looking at it if it's correctly mounted. So if you turn this one plus, it opens the door more. If you turn this one to positive, it closes the door more. And I'm assuming that's kilograms of force or something. Mind you, I've never messed with one of these before, so. But anyway, that broke off. But anyway, doesn't really matter. I'm scrapping it, but we'll try to get it to work if I can. Just play around with it. Might put some various things on the mott afterwards. See how much current they can take. Here we are. Finally figured out how to make it work. You just have this one wire here. It comes off the edge of the circuit board, and you touch it to that screw right there. And this is where your wires to your controller on the wall will be hooked up to. So touch that. Try to do this one-handed without getting shocked. There you go. And now if I let go of the wire, it automatically reverses. You have the relay clicking in there. Here's a better view of the switch, contact switch, so you have it try to focus on it. You have the switch right here where when it touches, it cuts the motor out. When this side here is for how far back it goes this way, and this other contact right here, or this part of the moving contact touches, and that is for how far it limits going to the other end. That will show you. As you can see, it stopped automatically. I did not let go of the wire. So holding it off, I let go. And touch it again. There we go. And it makes contact and it stops. Now, if it does not make its full travel, if it, let's say it just goes down halfway and there's an interruption to the signal to this screw right here, it will automatically return to where it's started from, like so. So now let go of the wire. There you go. Stopped. but if it makes its full travel one way or the other, and it makes contact to one of the contact switches, it will stay in that position where it stopped at. Bugger. Yeah, I just had to storage something out. And that's why I gotta be careful playing with stuff like this, because that's a lot of electricity, and I'm probably tripped the breaker, so I'm gonna check if that has been tripped, and we'll see if I haven't. Well, now that is unfortunate, so it did trip the breakers, and more importantly, it fried this trace on the circuit board, so it'll no longer work. I mean, if you try to make it work, the relay just clicks away, but the motor doesn't turn or anything, but it's okay. I'm scrapping it anyway, so it's not like it makes a difference, and I did get to show you how it works, so now I'll just tear into it further and continue dismantling it. This is a start capacitor, not a run capacitor, as I said earlier. I was wrong on that one, because usually these small engines have run capacitors, not start capacitors, but anyway. So here's a better view of how the distance adjusters on this move. So the screw, and you can see the contactor moves back and forth, so the further you set it, the longer it's going to travel. Same as with this one. And this screw here is driven off the worm gear off the front of the motor, which moves the moving part of the contactor. And you just have a basic steel auger go through an aluminum I-beam sort of thing, and this is where your garage door thing would hook onto and move your door, and then you got your emergency release if your power goes out, so you can open your door manually. And that just clicks down either way, I think. Yeah, it just goes one way. You slide it back and it goes click and clicks in. Doesn't matter which way you're going. You know, this way as well. Clicks right in. So yeah. Here's one more sensor I forgot to show. It sits in there just like so, and you can see. I'm guessing this is a sort of a laser pickup or something, or interruption sensor, because you can see there's a small, maybe probably you can't see it, the camera won't focus, but kind of like a laser LED or something like you can find in a computer mouse. And between this gap here, you have these rotating right here. So I'm assuming that the pulses between that going through there accounts how many revolutions the motor has done, and according to how far the door has gone. So yeah, other than that, there's not that much to it. You get the basic control circuit board, some various capacitors and relays, and the moving contactor, and it's the basic capacitor start induction motor. That's half horsepower, which, mind you, I'm not really quite sure the horsepower rating it says. It says half horsepower, but I'm not quite sure if that's after it has gone through the belt, which kind of gears it down. As you can see, the top pulley is smaller than the bottom one, which and then it is much reduced through the auger, because this rotates fairly quickly, and this moves quite slowly. So I'm not really sure if it's half horsepower at this, or that's just a motor by itself. But anyway, here you can see the shaft of the auger. You got the main output shaft of the motor up top, and there's the auger that goes through the bottom. So yeah, we'll continue dismantling it, and here's a closer view of the circuit board out of it. As you can see, you have your step-down transformer right here, which takes in 120 volts AC 60 Hertz and puts out 22 volts AC 60 Hertz. So it can be used by the various electronics on the board. You also as well have to have some diodes to convert to direct current, which are right there. That would be the relay that controls the start capacitor for the motor. So when you're opening and closing your garage door and something trips the laser safety or whatever you call it and it starts clicking, this would be that relay. Here's the capacitor. It's a motor starting capacitor. It's 53 to 64 microfarads and 20 220 volts AC, which capacitors are normally double the line voltage, so that's about right. Keep this. Have you ever wondered what would happen to your garage door if it didn't have any sensors on it to control how far it moves either way, and you pushed it too far? What would happen? Well, we're going to try that right now. So, bugger this electronics, because that's no good no more. Now, just simply wired it. Here you have your live, your neutral, and your starting capacitor for the starting windings. Running off my control panel. This is the one we're interested in. This is the main. This switch turns on all the windings, and this one, momentarily, you can turn on and turn off the start windings. And we're gonna push it till it pops. Now it only travels backwards since the electronic controls are gone, so I have to wind it all the way back with a cordless drill. Well, here we are. I guess we'll see what happens, and it is earthed properly, which is this wire right here, so if something doesn't go to ground, it'll be grounded properly, and well, here we go. That was quite disappointing. I was hoping it would break something, but anyway, let's see, maybe we can burn out the windings. You can see that noise tone change. That there's start windings on, there's just the run windings. I'll turn it off. This is how I have to reset it, because you can no longer go in reverse. So you just put it in a cordless drill on the inside of the motor. And much faster than the cordless drill. And it'll go, let's see what happens if we go too far. There we go, that was strangely satisfying. Try to get the drill off. Look. Put on the impact setting, comes off easier. Anyway, we'll resume with that in a minute. So, as I pretty much expected, its own motor is not powerful enough to damage itself in any way. It just stalls, which is... I was hoping it would break something, maybe strip the gears or break the belt off, but then again, this is not a very big, powerful motor, so it doesn't need to be. All it does is just move a garage door up and down, so... Here's the motor removed. It just sits in like so. And you gotta pull it out from the other side, just 4 screws hold it in. And it's hooked up to the auger through the spines via this coupler. It's on there. And the other end goes in there and turns the spines. Moves the thing. You got the better view of the belt on the other side of it. You can see. So yeah, there's not much to it. You just have this left, which is it. And you just have a long screw or auger, or whatever you want to call it, going through the length of this aluminum I-beam that hooks onto this and moves it back and forth. And uses, well, if you look carefully, you can see a plastic sleeve that rides in, which is greased, which is which is right there. You see that lip right there? From there on down is a plastic, kind of like a bushing, you could call it, so it doesn't ride on the aluminum and wear it out. So I guess that's it for this video. Hope you enjoyed it, and thanks for watching.